Hi, my name is Oriel Marshall, and I'm a PhD student at the universities of Copenhagen and Antwerp. I'm a member of the Chameleon Research Network, and this is a research group that looks into exoplanets, climates, and atmospheres, and modeling those computationally. So what you can see here are, on the left is an image of a climate model of an exoplanet showing where clouds would be likely to form. And then on the right is a map of a simulated Earth-like tidally locked planet showing where lightning would strike on this planet. And so clouds and lightning are two weather phenomena which are fascinating, especially within the context of planets outside of our solar system. And so what they're focusing on the network is creating these models of them. And so what I wanted to do with my research project, which is a interdisciplinary astrophysics and education project, is I wanted to look at looking at other ways of modeling these phenomena that can be used in the classroom that students can then use to talk about and learn about these topics. So because the computational models, these are whole PhD projects worth, so we found something that was a bit more appropriate for the classroom. And we developed these sets of materials. So if you want to hear more about the development of these, there's another talk in a different session where I talk about the process of developing these. So we have two different ones. The one on the left here is showing lightning. So it's using triboelectric charging and like static electricity to demonstrate lightning. And then the other one is creating a cloud in a jar where you use hairspray and water to show cloud nucleation within a jar. One of the important things to note here, just for practical reasons when we're discussing it later, is that the clouds are formed in the jar, and before you form the clouds in the jar, you wipe a bit of like washing up liquid around the inside of them so that it doesn't fog up on the outside, so you can see the cloud itself more clearly. Why I'm mentioning this will become clear later. So you can see I've got these two experiments, and these both represent cloud formation and lightning formation on an exoplanet. And so now to bring you to what we're actually doing with these in my current study. The research question we're looking at is, in which ways do students utilize student-led hands-on experiments as an analogy during post-lesson discussion? We'll break this down as a parts throughout this talk, just so that we're all on the same page and we can understand it thoroughly. So what we talked about just previously were these student-led hands-on experiments. The student-led there is that these are part of inquiry-based lessons. The experiments are what I just explained to you. But next up, I want to talk about what I mean by analogy in this setting. We're going to jump briefly to a bit of theory. So talking about conceptual metaphor theory. And so in this case, conceptual metaphor theory is this idea that you can have a metaphor by you can construct a metaphor by having a base domain or a source domain, which is concepts or ideas that a student already has access to, and then a target domain, which is a topic or subject that you want the students to be able to understand. So to take a basic example of, say, life is a highway. The base domain there is a highway, and you're expecting that people know certain things about a highway. And then the target domain there is life. So you expect them to map certain aspects of the base domain. So say, for example, a highway takes you on a journey to the target domain of life, which takes you on a journey. Now, what we're using here is physical analogies, which is a multimodal instance of these conceptual metaphors. So we're using as the base domain an experiment that students can interact with. And as the target domain, we're using a phenomena that we want this experiment to represent. So in our case, we're looking at the cloud experiment and the lightning experiment and how those could apply to exoplanet weather. Feel free to take a moment and just think about, are there analogies that you might use, physical experiments or analogies that you use in your classroom? And how you think students might use those. Okay, I've hopefully got some sort of ideas in your head that will just help as we're going through with this presentation. So we've now understood the analogy part of this research question, and now I want to explain what I mean by these post-lesson discussions. So the way that we set up this study was that we had 28 students aged 16 to 18, and we ran two different lessons. One was about the clouds and one was about the lightning. And the students participated in these lessons, and then after they were over, We split them into 8 different groups. Within these groups, we gave them a set of questions, written down questions, and we asked them to take their time, and they had a camera recording them and a dictaphone, and to talk through those questions, to take their time, and they took all between 9 and 16 minutes. The questions are as follows, where we said, explain what you did in your experiment. Why was each step of the cloud lightning formation process necessary to make cloud/lightning? Explain how you can relate what happens in the experiment to what you see here on Earth, what happens on an exoplanet, how do clouds/lightning form generally, and how do you feel that the experiment changed or added to your understanding of cloud formation? And then, are there any confusing or irrelevant parts of your experiments? Now, the reason that we did these in peer-led groups, so they were just self-led, is partly for practical reasons. There wasn't enough of us, the researchers, to be in all the groups, but also so that they had the freedom to present their authentic opinions. So they weren't trying to please the researchers or the teachers, that if they didn't know what was going on, then they could say that freely to their peers. So we then transcribed these focus groups. And what I'm going to talk through next is some of the themes and the ways in which we found the students using these analogies during these focus groups. So the first one is that students were able to map aspects of the base domain onto aspects of the target domain. So for example, this one conversation, the cold water at the top of the jar could be like the outer atmosphere. Yeah, and the hot water at the bottom could be like the heat from the Earth, like the surface of the Earth is warmer. So you see they're going between mapping aspects of the base to the target. Students identified elements of the base domain that didn't map to the target domain. This is where we come back to the dish soap thing. One of them said, I guess the dish soap is kind of irrelevant to the experiment itself because the only thing it did was help us visualize the experiment. So they realized that that is only part of the base domain, the experiment, and not part of exoplanet atmospheres. Next, we noticed that students were able to switch between the target and base domains when explaining the concept. So the first student says, there are 2 clouds. One is very positive and one is very negative. This is with the lightning experiment. The other says, no, it was more like they split up, like with the metal container. The bottom got very negative and the top got positive. So you see that one of them is using the target domain, the other one is using the base domain. So they can switch between these when explaining the topic to the other person. And then the fourth one we noticed was that students used the base domain as a reference point to seek clarification in respect to the target domain. So for example, one of them says, I don't know how the hairspray works. So for the cloud formation, you add hairspray. One says, that was the aerosol. Yeah, the little dust stuff. So the dust there is talking about the dust in the atmosphere of a planet, and the hairspray is talking about the domain. So we've split these into sort of 2 categories, one of them being that students could map and identify. They could identify elements that didn't map, and they could map elements, and that's sort of like internal processing. And then the other 2, where they're explaining it to the other person or they're seeking clarification, is when students are kind of using this almost shared language of the experiment to talk about the topic between themselves. So this is something that's more to do with the interaction with other students. And so what we can see here is that not only is using experiments like this, hands-on experiments, a useful way to explore often intangible topics, which astrophysics, as I'm sure everyone in this workshop is familiar with, can be quite intangible and quite hard to figure out how to actually have them interact with it in a more hands-on way. And so experiments like this, students can use these as a way as an analogy to learn more about these topics and to understand them more. And I think in addition to having students use the experiments to understand space, I think that in general, space and, exoplanets, but also just, in general, astrophysics can be a really great application and a way for them to, a way for students to map and expand the things that they've learned about, in the classroom and see it in a broader context and apply it to this larger sort of context. So that's everything that I wanted to share with you today. And I'm really looking forward to any questions that you have in the post presentation discussion. Thank you very much.